5,68,454 into 10, isn't it? We know what is user ID, we know what is profile name. What is this helpful numerator? Number of users who found that review is helpful, isn't it? That is helpful numerator, isn't it? Just let me, what is helpful denominator? Helpfulness denominator means number of users who indicated whether they found the review helpful or not. Means helpful denominator, you will get people, both type of people will come. There may be people who may say this particular review is helpful. They may say, they may not say also. Both people, that is help. For example, 250 people who said this is useful. Let me assume there are 250 people who said this particular review is useful. That will that will be treated as helpful numerator, isn't it? For example, there is 100 people who said this is not useful. Then in that case, helpful denominator, you will get yes as well as no. No is 100, yes is 250. 250 plus 100 will come to helpful denominator. Only people who said yes, who said this particular review is useful, that is known as helpful numerator. If you combine both, you will get helpful numerator as well as denominator. Isn't it? Actually, text plays a role, important role for rating. Anyway, how it is useful, we will try to understand. Just I would like to highlight what is this particular data set. Yeah, actually, what is the intention? Why we are introducing this data set? Why do we need? What is the purpose of this data set? Means actually, after building, by using this particular data set, actually we will train a machine learning algorithm. We will train a data science algorithm. For example, in this particular context, I will train a k nearest neighborhood algorithm. By using this particular data set, I will train a machine learning algorithm. For simplicity, let me say I am training k nearest neighborhood algorithm. Now, after training the model, after building the model, after identifying k nearest neighbor model, now if I give new review, it must say whether the review is positive review or negative review. Actually, it has got real-time application. It is implemented, not it is implemented project which is relevant, which is applicable, which is useful. Still, people are using even not only Amazon Fun Food Review. It is the algorithm which is used by many reviews. That may be there may be different reviews, isn't it? Actually, once if I train a k nearest neighborhood model, now if I get a new query, if I get a new review, we cannot process on a daily basis. You may get lakhs of actually now you may get lakhs of reviews, but it is very difficult to process by human beings, isn't it? That's why we need a machine learning algorithm which can process many reviews at a time, depending on that reviews. What is the use of reviews? Actually, what is the review use? You can identify if there are any drawbacks, if there are any pitfalls, if you're on your product, if it is useful, which feature is useful, which feature is not useful. You can review about your product. You can what you can do. You can perform. You can see positive reviews. You can see negative reviews. Positive reviews will teach something. Negative reviews may teach something. Depending on that reviews, we can improve our product. Basically, idea is with this KNN algorithm. Once if I train this KNN algorithm by using this particular data set for new queries, it will automatically say which reviews are, how many reviews are positive, how many reviews are negative. Once if you have that clarity, understanding things, understanding things is simple, and it's simple and straightforward. Actually, I would like to highlight about this particular data set. Once if you understand this particular data set, now we will try to understand this particular algorithm. Which algorithm? Let's go to k nearest neighborhood algorithm as how this is useful for understanding different techniques. Just let me go back. Generally, there is something like 4-star review, 5-star review means I can say it is a positive review. People may say 2-star, 1-star. 2-star, 1-star means we can treat it as negative review, isn't it? 3-star means you can say it is 3-star means it's, I can say it's a neutral. Isn't it? It is 2-3-star means you can treat it as neutral. How it works, we will try to understand. Just let me go back. If it is positive review means what? Positive review means it is useful, isn't it? That's what positive review means, isn't it? Yes. Now let me go back. Let me go back to this particular. Let me see this next one. Actually, what it says. This is actually loading Amazon Find Food review data set. Loading it is a simple in the context of k nearest neighborhood. We will try to. This is deduplication means it is something like deduplication means it's a pre-processing step. Just I would like to show the titles. But as today's discussion is related to k nearest neighborhood algorithm. Actually, if we speak strictly, in order to work with this particular data set, we need natural language processing. Natural language processing means there you can understand text to vector conversion. Text to vector conversion means you can see something like bag of words, TF, IDF, all those things. Just see, this is bag of words. As this this is actually, as per our schedule, we are not discussing natural language processing. Just I would like to show the titles. Actually, we are interested in understanding k nearest neighborhood algorithm. Anyway, bag of words, all this machine learning algorithm cannot understand your review text. It needs some sort of pre-processing. This bag of words technique is known as pre-processing. Just that is about 254, 255. It is Amazon for stemming and lemmatization. That is also related to NLP, but we are not interested. Bigrams, unigram, bigram, trigram, n-grams. Again, this is related to. What is this? NLP. This is 257 TF-IDF, term frequency, inverse document frequency. This is also related to NLP. As I told you, in this particular session, NLP is not included. This is also word to vec. This is also just I would like to show the titles. This is weighted one. Next, just let me. This is a count vectorizer. This is also related to natural language processing. This is a text processing. Just wait for a few seconds. Review data bag of words. Just wait for 1 or 2 seconds or 1 or 2 minutes. We will come to the original discussion. Yes, just I'm searching. This is code for TF-IDF. Yes, this is just till I get k nearest neighborhood algorithm. Let me search. Yes, this is 268. Just I would like to show the yes. Actually, Amazon Find Food review data set data matrix. Yes, from here you should learn. Actually, why am I skipping all those things? All those are related to natural language processing. Natural language processing is not part of this particular professional development program. We will conduct another program there. We will discuss. Let us restrict ourselves to now in this particular session. We would like to understand k nearest neighborhood algorithm. To understand that algorithm, I need particular data set. Therefore, I introduced that Amazon Find Food review data set. Yes, what is this data matrix? How it works? Now we will try to understand this data matrix. Lecture number 268. Let me go to 268 lecture. Just bear with me for a few seconds so that we will try to understand it. Just see what it says. Yes. This one is data matrix. Actually, how one can construct data matrix, that is important. What you have here, as we are discussing, why do we need this data matrix? Actually, to apply k nearest neighborhood algorithm, I need some sort of data, isn't it? To apply the principal component analysis, I need some data. Few minutes back, we have seen Tisne algorithm. For Tisne algorithm, I have shown different pictures. What are those pictures? I don't know how many of you remember. He said in that particular box, 50 pixels of sample 1, 50 pixels of sample 2, 50 pixels of sample 3. In order to apply any algorithm, I need particular data set. In order to train my algorithm, I need particular data set. This Amazon Find Food review data set. Actually, just try to recall what we were saying. Few minutes back, we were saying that each review can be treated as a row, isn't it? A review means your machine learning algorithm, your k nearest neighborhood algorithm cannot understand review text. Therefore, we need some sort of feature engineering. What is this feature engineering here? I already skipped a few lectures. That skipped lectures will taught us how to feature engineering. Yes, let me say RI. RI means what? My ith review. R1 means my first review, R2 means my second review, R3 means my third review. Maybe in this particular data set, as per my maybe I think few lakhs, maybe just I think there are how many are there? As per my understanding, 5 lakhs 68,454 reviews are there. Just try to recall. In the on that particular data set, I have 5,68,454. My dear friends, how many reviews RI means? Generally, I'm saying RI. R1, R2. R1 is my first row, R2 is my second row, R3 is my third row. My last review is R84,054. Actually, here, what's happening here? Each review, if I keep reviewing data matrix, your k nearest neighborhood algorithm cannot understand anything. For that, what I have to do? I have to convert this review. I have to convert this review RI into a vector. Who will convert this one? I skipped a few lectures. That may be bag of words, that may be word to vec, that may be text to word vector. There are different natural language processing techniques. That may be n-gram, that may be bigram, that may be trigram. There are different NLP techniques which are useful. There are different natural language processing techniques which are useful for converting your review text into a vector. That is important. RI. RI means ith review. I'm converting into a vector. Let me say that vector is xi. What is this xi? Xi is a vector corresponding to review I. How I got this xi? By using NLP techniques like bag of words, text to vector, all those things. Just let me go back. Now I have got vector xi. Just see, that's what I'm writing here. Ri from review I will get xi. By default, I'm saying xi is a vector. By default, vector means what? By default, vector means it's a column vector, isn't it? My xi, it is a column vector, isn't it? Xi is a column vector. Now, what am I doing here? I'm writing xi transpose. Xi is a column vector means xi transpose is row vector. Just try to recall our MNIST data set also. We converted 28 by 28 pixel image into 784 by 1. That column vector, we kept it as row vector for data matrix 1 by 784. Here also, I am taking review data, I am taking review text, I am converting it to vector, I am treating it as xi. Xi is a vector. Basically, it is a column vector. I am taking transport. If I take transpose to this column vector, I will get row vector. Here, this is xi transpose. First row, x1 transpose. Second row, x2 transpose. Third row, x3 transpose. Last row, x 56,8484. 54. You will get like that, isn't it? Yes. Same thing I am saying. This is xi transpose is a row. In general, I am writing xi transpose. That may be x1 transpose. That may be x2 transpose, x3 transpose, x4 transpose. So on and so forth, isn't it? Yes. Here, what is my outcome? That review may be positive review. Review may be negative review. When will you say review is positive review or negative review? We were saying that rating is, if it is rating is 4, 5 positive, 1, 2 negative, something like that. We were saying, isn't it? Now, what we have to do? Here I am writing y equal to f of x. What is this y equal to f of x? We will try to understand. X is my input data. This is x is input data. This f means that this f. We would like to train a model. We would like to build a model. What model will you build? I have points xi, yi, x1, y1. What is my x1? My x1 is first row. My x2 is second row. My x3 is third row. What is my last row? X is 56,454. I have rows x1, x1. Otherwise, let me say x1, xi, comma, yi. I have got yi for each xi. Means I already discussed. When can I say positive review? I will see the score. If it is 4, 5, I will give positive rating. If it is 1, 2, I will give negative rating, something like that. Actually, if you speak strictly, here I have to do some sort of pre-processing that I will discuss. Time being, if you have any difficulty, my dear friends, please ask. It is a d-dimensional vector. Here d means, time being, d means 10-dimensional vector. I already discussed 10 dimensions, ID, user ID, text, product ID, summary, all those are, let me say, in general, d-dimensional vector. How many points, let me assume? I am assuming there are n points. How many dimensions? D dimensions. Is it labeled data? Yes, it's labeled data. Why? Because for each review, I can give either positive rating or negative rating, isn't it? This I can say it is labeled data. I have got few points. Just see, that's what I'm writing. I have n points. For each point, for xi, I have yi. For x1, I know what is y1. For x2, I know what is y2. For x3, I know what is y3. For xn, I know yn. Means this is labeled data. How many reviews in this data matrix are there? There are n reviews. Therefore, there are n rows. How many dimensions? Let me assume d dimensions. Therefore, what is this yi? Yi size is for each review. For this, we are building a data set. My dear friends, first understand data set. Till now, we have not built a model. We need a data set to feed the model. We need the data set to build the model. We need the data set to train the model. Therefore, first let us try to understand data set. Which data set? Amazon Fine Field Review data set. In general, I can say it is n cross d matrix, n rows, d columns, and each xi has got some label yi. That may be positive review, that may be negative review. Just see how am I writing this one. Just see, d equal to xi comma yi. This particular, just my dear friends, this entire matrix. Here I have one matrix and column vector. I am representing this entire matrix and column vector like this. Capital D equal to xi comma yi. I equal to 1 to n. Xi belongs to R power D. What does it mean? Xi means xi is d-dimensional vector. Why? Because here you have d columns. Therefore, it is d-dimensional vector. What is my yi? I have two reviews. Only two possible reviews I am considering. One is positive and another one is negative. Therefore, yi belongs to 0, 1. 0 may be positive, 1 may be negative, 0 may be negative, 1 may be positive. Depending on your convenience, you can assign whichever number you want. Here we are assuming 0 is positive and 1 is negative. Enter this matrix, n cross d matrix and n cross on column. I am representing just like a set. Capital D equal to xi comma yi, I equal to 1 to n, xi belongs to R power D, yi belongs to 0, 1. Just try to understand this. Yes. This is my data set. What is my data set? My data set is this. 0 means negative, 0 means negative, 1 means positive. Vice versa also it works. It doesn't matter, isn't it? Anyway, this is my data matrix. This is mathematical representation of data matrix, isn't it? That first, if you understand data matrix, first you must understand data matrix. Then you can understand different concepts. Actually, what it says, again, maybe I'm repeating. I have review Ri, for which I am constructing xi. For each xi, I will get yi. That may be positive review. 0 means positive. 0 means negative review. 1 means positive review. I have xi comma yi. Pair this xi comma yi pair as training data. This data is training data. Why? Because in last session also, MNIST data set, we were saying that there are 60, if you go to Wikipedia, there are 60,000 handwritten digits. That is training data. We were saying, of course, if you download from Kaggle, it shows only 42,000 size for applying Python code. We reduce its size to 15,000. It doesn't matter. Anyway, here xi comma yi pair as training data, and it learns function f, for which, yes, for each input is xi. by using this data, I must find f, I must find a model, I must find a function. Yes, here my model, in this context, we will try to understand about, in this particular context, we will try to understand, try to understand about KNN algorithm. Classification is all about, what is classification? Classification is all about learning this function. Yes, this is KNN is basically classification algorithm, isn't it? Actually, this is simple algorithm. You may ask me why you are taking this simple algorithm. Actually, actually, I would like to introduce different concepts. That's why we opted this particular algorithm. Otherwise, just wait 1 minute. Just let me go to Google search. Let me search for KNN algorithm, what it says, so that we will proceed. There is a reason for choosing this particular algorithm. Maybe you can understand after a few minutes why I opted this particular algorithm. I would like to explain. I would like to explain something like overfitting, underfitting sort of constant. Just see if you see KNN algorithm. If you we are image, I did image search, isn't it? I'm getting many articles related to k nearest neighborhood algorithm. Just see what is KNN algorithm. What is the questions they are asking? What is KNN algorithm in machine learning? Is KNN is supervised, unsupervised? What is the equation for KNN? What is the k nearest neighborhood algorithm? A complete analytic with IBM. Yes, W3 schools. Just there's so many articles, isn't it? Just how to leverage KNN algorithm in machine learning. All this actually, while building this lecture series, I referred so many websites, so many blogs, video content, and by referring all those things, I built this lecture series. Anyway, we will try to cover, we will try to answer all these questions. Let me go to, this is actually, let me go back, let me continue my discussion. This is 268. Let me go to 269, what it says. Yes, classification. Actually, till now we discussed how classification works. Classification works means, just we discussed about data set. We were saying that you have training data set. You have to build a model F. Here in this context, F means k nearest neighborhood algorithm. Here we will try to understand classification versus regression. Of course, you have classification algorithms as well as regression algorithms. Just anyway, just let me recall what is classification, what is regression. I will spend only few minutes time. I will not take much time here. I will take only few seconds. I will just see this one, recall. Just try to recall what is my D. Just which my D is xi comma yi, I equal to 1 to n. Xi belongs to, this is about my Amazon find food review data set. Xi belongs to R power D, D-dimensional vector. Your yi belongs to 0 comma 1. What is this? What is this? 0 comma 1 means, what is 0? What is 1? We were saying that 0 means negative class, 1 means positive class. Means this is related to classification problem. This Amazon find food review data set, once if apply k nearest neighborhood algorithm, it classifies given text. If you given review text, if you feed review text to this particular algorithm, it will tell whether that review is positive review and negative review. Again, I am re-emphasizing things. Why do we need to build KNN algorithm? Why? Because you may get lakhs of millions of reviews. It's a very difficult to process by a human being. That's why we need some machine learning algorithm. Here KNN works. KNN is useful for identifying whether particular review is positive or negative, isn't it? Yes. To actually, here, how many classes do you have? Here you have 2 classes. Here this is 2-class classification problem. I can say one is 0 class, that is negative class. One is positive class, that is positive. This is basically 2 class. I can say it is binary classification problem. What about my MNIST data set? Till now I discussed about my Amazon find food review data set. Now we will try to understand about MNIST data set. For each of the image xi, just try to recall what is my MNIST data set. In MNIST data set, I have images. Just what images I have? I have handwritten digits. All those digits are there. They took pictures with some camera, and each picture size is 28 by 28. Each xi, in the case of MNIST data set, each xi represents an image. What is your yi? Your label? Well, there are 60,000 training images. There may be few zeros, there may be few ones, there may be few twos, there may be few nines. Totally, there are 60,000 training images. But how many labels? How many labels do you have? In the case of MNIST data set, you have 10 labels. You have only 10 labels. Label means I can say classes. How many classes do you have in MNIST data set? In MNIST data set, I have 10 classes, class 0, class 1. They will give one picture. Your algorithm must say whether it is 0, whether it is 1, whether it is 2, whether it is 3, whether it is 9. How many classes are there for MNIST data set? There
Sir, you are not audible, sir.
Sorry, sir. Now is it okay, sir? Nageshwara, sir?
Yes, sir.
Yes, sir. Now it is audible, sir. Thank you.
Nageshwara, sir, we are so thankful. You are really motivator for us. Actually, you joined for even I used to myself get motivated early morning. I have seen you. You are walking. I don't know jogging or walking or running at this age, and at this age you are joining for our session.
Thank you. Thank you very much, sir.
Thank you, sir.
I am so fortunate, and institution is. I feel we are so fortunate, like a very learned personalities available with us in a living. Okay, physically we are able to contact you and we are able to get the doubts cleared, sir. Thank you very much, sir. Please proceed, sir.
Oh, mine is very simple, sir. Actually, really, thank you so much, sir. Actually, maybe I don't know. Maybe it may not correct platform to say so many things. Thank you, sir, for correcting us. Yes, now is it audible, sir?
Yeah, very clear,
yes,
clear, sir.
Yes. Actually, if you discuss in the case of yi means label. If it is positive, negative, that is 2 class. If it is 0 to 9, 10 classes, that is classification problem. If yi belongs to real number set, if your yi belongs to real number set, I can say that is regression problem. For example, regression means people used to say linear regression. That is if you would like to predict house prices, that is regression problem. It's not classification problem. Actually, maybe we would like to conduct maybe another knowledge sharing session after this particular FDP. There we will discuss about logistic regression, linear regression, their performance analysis. Actually, it is included in our second year syllabus. Second year students, we would like to conduct one more FDP or knowledge sharing session. There I will discuss. Time being, just understand here I equal to, let me say I have xi. In xi, I have weight, age, gender, race. This is my xi. Now, what I have to predict? I have to predict yi. What is my yi? I would like to predict height of an individual. By which data set I would like to predict? By that person height, that person weight, that person gender, that person race, all those things. By using those features, by using weight, age, gender, race, by using these x, I would like to predict yi. Yi means height. Let me assume here predict height. Height is a real number. Once if yi belongs to real number system, I can say once if it is real number system, I can say it's a regression problem. Simple. If your class label, related to real number system, that is regression. If it is related to something like 0 class, 1 class, 0 class, 1 class, 2 class, 9 class, otherwise that may be gender, male, female, otherwise that may be review, positive review, negative review, depending on your yi. Simply I can say, if your yi belongs to real number set, it is basically, if yi belongs to real number set, I can say it is a regression problem. Otherwise, if you have classes in yi, I can say it is classification problem. Let me go back and I will continue. This is maybe I think 269. Just let me show you next one, that is 270, what it says. Yes, this is actually in machine learning, many people used to say this one: understand everything with geometry. Not only in machine learning, it is applicable for all branches of engineering. That may be physics, that may be chemistry, even that may be civil engineering, that may be mechanical engineering. Understand things from geometrical perspective. It will give good insight on that particular algorithm. That's why now, as we were saying, that our main motto, our main intention is to understand k nearest neighborhood algorithm before explaining, before understanding mathematical interpretations. Now let's try to understand simple geometric interpretation or geometric intuition of this k nearest neighborhood algorithm. Let me consider two-dimensional toy data set. As I told you in last session also, we were saying that actually, I don't know how many of you remember in last session, if to understand dimensionality reduction, we reduced two-dimensional data set to one-dimensional data set. Why we reduced means it is easy to understand 2D to 1D, but honestly, you need not convert 2D to 1D. Why? Because 2D is itself is you can visualize that data. But once if it works from 2D to 1D, that is the power of linear algebra. In last session, we were saying that this is power of linear algebra. You can use linear algebra to extend this 2D data to ND. Therefore, now let us try to understand. Let us try to understand geometric intuition of this particular algorithm by using two-dimensional toy data set. How it works, just we will see. Just see this one. Yes, actually, here I have two types of data points. One is positive data points and another one is negative data points. Actually here I have two colors. Let me assume my blue color is positive data point and my red color is negative data point. I have two types of data points. Actually, I think anybody can understand. Maybe better way of representing this one is using plus symbol and negative symbol, minus symbol. Plus means positive review, minus means negative review. Anyway, somehow I realized that after recording this lecture, I realized that instead of keeping colors, if I symbol plus and minus, it may be suggestible. Anyway, it happened. Now, time being, just understand. I have two types of data points. One is blue color data points and another one is red color data points. Let me assume my blue color data points are positive data points and my red color data points is negative data points. What is this dimensionality of this particular data set? It is two-dimensional data set. Why? Because I have x-axis as well as y-axis. Therefore, it is 2D. Isn't it? That's what Jesse I'm writing here. This blue indicates positive and your red indicate negative data points. Now this is my entire data set. That's what it says. Jesse, what is this? This is my data set, isn't it? My data set is xi comma yi. Your I equal to what can I say? Says that xi belongs to R2. That's important. Here xi belongs to R2, my dear friends. Earlier, just let me wait for a few seconds. There, in the case of Amazon Fine Food Review data set, xi belongs to R10. There are 10 dimensions. For example, in the case of for example, in the case of MNIST data set, your xi belongs to R power 784 dimensional point. In the case of IRIS data set, it is of the dimension xi belongs to R power 4. Here, this is two-dimensional data set. Therefore, I'm keeping xi belongs to R power 2. It has got two dimensions, isn't it? Your yi belongs to 0, 1. That may be, that's what I'm saying. 0 is a negative class, 1 is positive class. Here, negative class I'm indicating with red point, 1 is indicating positive point. I request all of you, let me take 5 minutes break. Let me have water for 5 minutes. I think it is 12:06. I will take exactly 5 minutes break. I will again join at 12:11. Thank you, all of you.
Okay, sir. Thank you, sir. Sure, sir.
Thank you.
Dear participants, again we'll continue our session after 5 minutes. Dear participants, just wait for a few more minutes. Very soon, sir will continue the session.
Yes. Am I audible?
Yes, sir.
Yes. Just give me 1 minute. Okay. Yes. Anyway, what we were saying. This is the data set. I am representing Xi belongs to R2. Why? Because here I have it's a two-dimensional data set. Here Yi belongs to 0, 1. 0 means negative class. 1 means positive class. Just I am representing. Just I'm taking a toy data set. This is a toy data set. Toy data set means it is something like hello world program in learning some C or C++ Java programs. It's just like hello world type database, not more than that. In order to understand things in simple manner, just I'm taking the simplest data set. Once if you understand this particular algorithm, k nearest neighborhood algorithm for this particular data set, certainly you can apply for other data sets. Yes, actually what it says, just see. Okay, just let me move. Yes, what is this? I have a data set D. Now what I have to do? I need a machine learning algorithm. Here machine learning algorithm means F. F means function here. F means function, F means model, F means algorithm. This F can be an algorithm. This F can be a model. This F can be a machine learning algorithm. What will it do? By using this particular D. D means data set. Which data set? This data set is known as training data set. This capital D is basically training data set. By using that particular training data set, I will build a model. After building model, what I have to do? I will get a query point, XQ. That XQ, I have to feed this F. How I got this F? I got this F because of this training data. This F, now I can make use for a new query point XQ. If I feed this new query point XQ, for this F, output will be either positive or negative. Why? Because this is binary classification problem. Yes. Just if you see, this is about k nearest neighborhood algorithm. Actually, here I have only two classes. One is positive class and another one is negative class. What is our convention? What is our notation here? We are saying that blue is positive, red is negative. But here I'm keeping another data point. This is neither blue nor red. Now I need what is the class of this particular data point, isn't it? As according to k nearest neighborhood algorithm, I will categorize this point either blue point or red point. Blue means positive, as red means negative. But this particular algorithm says what it has to do. It has to identify neighbors. How many neighbors it is taking? 1, 2, 3, 4. These 4 neighbors are basically blue points. Blue data points means positive points. Therefore, what label will you assign? Which label will you assign for this particular data point? If you speak strictly, what label will you assign? You have to assign blue label. Blue means positive. Why? Because it is surrounded by which point? Blue points. Actually, I am saying something about training, but if you speak strictly, in the case of k nearest neighborhood algorithm, there is no such hardcore training. Why? Because here, anyway, those points I will discuss. Time being, just understand here you have to take a nearest neighboring point and assign that particular label. This is a simple lecture. Anyway, just let me proceed. Let me continue this interpretation. This 271 also says geometric interpretation only. The simple interpretation, what it says, we will try to understand. Yes, same thing. Yes, recall, given XQ, what you have to do? You have to find YQ. Here, given XQ, we already find YQ, depending on its neighbors, isn't it? Your YQ belongs to 0 or 1. This already we discussed. Just we are recalling all these things, isn't it? What is this? Capital D. This find k nearest points to XQ in my data set. How many nearest points you have to find? Actually, just try to recall. Actually, here in the k nearest neighborhood algorithm, this k This K is known as hyperparameter. Anyway, I will discuss about those hyperparameters. For simplicity, just you are considering this this particular data set. Just I am assuming K equal 3. Yes, you may ask me, how do you know whether K equal 3 or 4, 5? I will discuss about how to find right K. Actually, here there is something like cross validation. I will discuss about that cross validation in my next lecture. Maybe in tomorrow's lecture, I will discuss about cross validation. There we will try to, there is something like 10-fold cross validation, K-fold cross validation. There I will discuss about how to find right K. I will discuss. Time being, just assume that I'm assuming K equal to 3. K equal 3 means, for this is query point XQ. What I have to find? I have to find the nearest 3 neighbors. Nearest means, you may ask, how do you know nearest? There are different performance measures. There is something like Euclidean distance. There is something like Manhattan distance. There are different. There is something like cosine similarity. All those things are simple. Euclidean distance, Manhattan distance, cosine similarity. All those as they are very simple. I'm skipping that part as it is elementary thing. But try to understand. There are measures which are useful to identify nearest neighbors. Why I am considering only 3 means because K equal to 3. This as these 3. What is these 3? These 3 are basically, I have xi for x1, xi, yi means x1. What you are getting here? Just see how many neighbors you have here. 3 neighbors. Let me say first neighbor is x1, second neighbor is x2, third neighbor for whom it is neighbors, for xq. This query point, for this query point, the new point, for this query point, your neighbors are this one. Let me say this is x1. Just say this is x1, this is x2, this is x3. What is the label for x1? For x1, it's a blue point. Blue point means positive label. Y1 is positive. For x2, what is the label? It's a blue point, positive label. X3, Y3 is a positive label. How many positive labels you have here? You have 3 positive labels, isn't it? Actually, there is something like majority vote, isn't it? Majority vote means here all of them are positive. Therefore, I can treat this query point, your YQ corresponding to XQ is positive label. Otherwise, there may be other possibilities. What are the other possibilities? Imagine, let me say, you have 2 positive points. Let me say x1, x2, x3. Let me assume y1 is positive, y2 is positive, y3 is negative. Means how many positives? 2 positive, 1 negative. Which one is majority? Majority is positive. Therefore, your YQ belongs to positive. Actually, you must take K as an odd number. In K nearest neighborhood algorithm, your K must be odd number. Otherwise, what happens if you do? Let me say, if you keep K as odd number, you won't get tie. Isn't it? For example, if K equal 4, if you get 2 positive points and 2 negative points, it's difficult to determine which. What is YQ? Of course, therefore you should avoid. You should always try to avoid even numbers. Always try to take K as a odd number so that you will get majority vote. Of course, there is something like weighted K mean. Those things I will discuss in next lecture. In this lecture, time being just understand this one. Just treat K as an odd number. How to find right K also we will discuss. If there is a tie, what you have to do? There is something like weighted K mean. That also I will discuss maybe in next class, in tomorrow's session. Just time being, let me proceed. What is this? This is related to KNN failure cases. There is a separate lecture, limitations of KNN. There are limitations. The limitations is different from failures. That limitations I will discuss. Time being, just see failure cases of K nearest neighborhood algorithm. There are 2 cases. This is case 1. What it says case 1? What is this? Actually, there are just I have 2 cases. This left side portion is one case, right side portion is another case. Case 1, case 2. Let us try to understand each of these cases. What is my case 1? Just let me take these data points. Let me say I have a query point XQ here. If this query point XQ, let me say K equal to 3. If I say K equal to 3, what happens? I have to take 3 nearest neighbors. All those 3 nearest neighbors are positive labels. Therefore, your XQ, your YQ must be positive. Why? Because it is surrounded by positive points. If I take XQ here, What happens here? Your YQ will be red. Red means you will get negative point. It's okay, isn't it? What happens if I take, these are different cases, isn't it? If I take XQ here, if I take XQ, there are different places where you are considering XQ. Yes, it's fine. Earlier it's fine. Now what's happened, Jesse? Yes, here it's okay. In these all these cases, okay. Here let me say case 1 is okay. Here let me say case 2 is okay, isn't it? Here this case 3 is okay. Here also it's okay. But what happens? What happens? Your query point XQ is far away from all these points. Let me assume this is very, very, very far away from all these points. You may ask me, how do you know that distance means? As I told you, there are measures, cosine similarity, Manhattan distance, Euclidean distance. They will give this particular query point XQ is far away from these points in data set. In that case, what will you do? Let me say K equal to 3. If K equal to 3, I will identify 3 neighbors. Let me assume this is my first neighbor. This is second neighbor. My third neighbor. Let me assume this is an assumption. As per majority vote, I must give label for this XQ. My YQ will be blue, means positive. But is it really sensible? Is it real? Is it not absurd? It is untrue. It is absurd. Why? Because your data point itself is so far away from this the other points. In such case, you cannot say this is positive, this is negative. Here also just say I'm taking another point which is far away from the existing data points. Just again I will same thing I will discuss. Here it is a difficulty. If your query point is very, very far away from existing data set, then it is difficult to determine. In similar manner here, if you have jumbled type of data, it is jumbled data points. In this particular case also, determining YQ is very, it is most likely it will give wrong result. It's mixed data. It is, I can say, some sort of noisy data. It is simple, straightforward. Anybody can understand. That's why I'm a little bit fast. Just listen this lecture. I already explained in neat and detailed manner. That is about 272. Yes, let me say there are this is accuracy of KNN. Of course, actually in this lecture series there is one particular unit, performance measures. Of course, here accuracy means I can say it's effectiveness of k nearest neighborhood algorithm. Here we are using accuracy, but if you speak strictly, accuracy is not only one measure. There are many cases whereas accuracy will fail. There is something like F1 score. There is something like sensitivity. There is something like ROC curves. All those things. There is separate, maybe maybe after 1 or 2 days we have a separate session on performance measure. Those people who are really writing, if they are new people writing papers or doing PhD, that particular session is very, very useful. Why? Because if you write paper, ultimately you have to measure the performance. Many times people used to keep just accuracy only measure, but in reality accuracy does not work in all situations. But here in this particular session I'm discussing accuracy, but I will discuss about other different measures in future sessions. Maybe after 2 to 3 sessions I will discuss, maybe day after tomorrow. I request, so those people who are really serious in research, please attend that session. That certainly that will add value to your career. If you know, it's okay, it doesn't matter. Yes, actually let me recall what we were saying. This is data set. Maybe you earlier we were saying that there is a big data set. Maybe just if I recall, what is the data set size? Maybe I think it's 5,68,454. Just recall, initially when I discussed about this data matrix, we were saying that my data set size is how many rows? 5,68,454. Unfortunately, no. Actually, what I did, we can perform some sort of pre-processing. After performing pre-processing, after performing deduplication, actually in between I skipped a few lectures. In those lectures, I explained how to remove deduplications, also all sort of things. After deduplications, after pre-processing, how many data points will you get? You will get 364K data points. Just that's what I'm after deduplication and cleaning. As I told you, maybe it's a repetition. Maybe okay. It's nice thing to recall. Therefore, I'm repeating. What is RA? RA means ith review. R1 means first review. R2 means second review. RA can be converted into vector. Why we are converting it into vector? Your machine learning algorithm. I cannot feed reviews to I cannot feed reviews to k-nearest neighborhood algorithm. It cannot be a data point, isn't it? I need some sort of pre-processing. That pre-processing is bag of words. That pre-processing is TF-IDF. That pre-processing is W2M, means word to vec. Means this review text will be converted into numerical vector. That isn't it? That's why this comes under natural language processing. That's anyway, as it is not that relevant to present today's session, I skipped that part. If someone is interested, they can go through those lectures. Of course, finding bag of words, TF-IDF, WT, word to vectors, they are simple. But timing, just understand, I have a review. I'm converting that review into vector by using a NLP techniques like BOW, TF-IDF, word to vec. Now I'm getting XI. This is not new thing which we already discussed, isn't it? Actually, what is your YI? YI belongs to 0, 1. This is data matrix D equal to 1 to n, n rows, XI transpose. Here you have YI, isn't it? Now accuracy means what? What is the effectiveness of KNN? Here problem. How good is our KNN? That is important. After building the model, even if you write a paper, if you devise some mechanism in result, in conclusion, you need some sort of performance measures in which here you are using accuracy. Again, I'm reiterating, accuracy is not only one measure. There are other measures. Accuracy may not measure many insights of your data set. There are many failures. There are so many drawbacks of accuracy measure. What are that may not work for all types of data sets. There may be imbalanced data set. Those things I will discuss in future session. Time being, just understand effectiveness means just let me calculate what is the problem here. After building a model, given a review, means this is a review RQ, Qth review RQ. Now I must find polarity. Polarity means you must say whether it is positive review or negative. That is polarity, positive or negative. Given XQ, query point, we want to determine what is YQ. That YQ, your YQ may be positive, YQ may be negative. That your algorithm should determine, isn't it? Accuracy is simple and straightforward. Why? Because what you used to do, just you have to maintain a counter, just the same thing. Here what I am saying, just n equal 364k XI is data set. You have corresponding labels. This is labeled data set, isn't it? What I did, this is DN. DN is just I'm converting splitting into DTrain and DTest. In DTrain, I am keeping N1. Please don't get confused. Training of KNN. Just for my convenience, I am splitting this data set. If you speak strictly, there is no hardcore training for KNN. Just it's a matter of loading all the points in RAM. That's it. Nothing more than that, isn't it? Anyway, this just my convenience. For sake of my convenience, I am converting this DN into DTrain, DTest. In DTrain, I have N1 data points, DTest N2 data points. N1 plus N2 means that is N. N is size of entire data set. That DN equal to DTrain union DTest. There is and if you find this is non-overlapping split. Intersection is empty set. How do you split? The splitting is training and testing. There's a random sampling. There are different ways of sampling. There are time-based slams, time-based splitting, random splitting. Just time being understand, I am splitting the data points into in random manner. Usually your training data set is 70%, your testing data set is 30%. Of course, it may vary, sometimes 80% and 20% also, depending on your data set, depending on your nature of the problem, depending on the nature of the algorithm, that may vary, but generally you can say 70-30 like that. Yes, what I did, I collected DTrain and I apply for just I'm using KNN algorithm, isn't it? For KNN after applying KNN algorithm, yes, what is my DTest? After collecting, just I'm trying the model. Just for XI belongs to DTest, I'm collecting query points or data points from DTest, and I have to feed that model. After feeding the model, what happens? Just what is that? That may be true, that may be false, which may be true, which may be false. Your prediction may be true, your prediction may be false. Yes, for that it is a simple C program. Just see here what I am doing. Here just see CNT means counter equal 0 for each point in D test. Actually, by using D test only, I must find accuracy, isn't it? XQ equal to point means every point. Just see, I am collecting each point in D test. That point I am keeping in XQ. What I am doing, using dtrain and KNN to determine YQ. Now I am determining YQ. What is my K? Earlier we were saying that K equal to 3. Just I am saying, time being we are saying that we know that if K is even number, we have difficulty. Why? Because majority vote doesn't work. For K equal to 4, if 2 positive, 2 negative means how will you get majority vote? That's why K should be negative. Yes, we were saying that how to find right K. That I will discuss. As I told you, that I will discuss in next session. That is in tomorrow's session. That how we can do cross validation. All those things we will discuss. Here K equal 3. Just by using this data set, what I am doing, majority vote for XQ using dtrain and KN, I determine YQ. Then this counter will CNT equal to 1. CNT equal to 1 means that counter will get incremented for each correct label, isn't it? For correct identification. Count is number of points for which my dtrain plus KNN gives correct class label. I am keeping a counter whenever it is identifying. This counter get increment. This now in counter, what can I store? Number of correct classifications. N2 means what? N2 means how many? N2 is size of the D test, isn't it? What is the size? dtrain size is N1. D test size is N2. This is total number of points. Number of correct classification by total number of points in D test. Actually, the accuracy is always lies in between 0 and 1, isn't it? This formula says worst case you will get 0. In best case, you will get 1. If you speak strictly, as I told you, this accuracy. Yes, actually, I'm saying that's what. Actually, there is a name. Actually, for KNN, there people used to say lazy learner. Why it is lazy learner? There is no training phase if you speak strictly. It is a matter of identifying number of nearest neighbors, nothing more than that. Here there is no explicit training. In KNN, what you have to do, I'm saying training repeatedly. You may ask me, if there is no training, why you are saying that your data set is splitting into 2 sets, dtrain and dtest means similar, it's simple thing. Just I wrote here, just see, in KNN, the training phase consists of loading all the training data points into RAM. That's it. There is no explicit training. Simply, I am loading data points in RAM. I am keeping that itself is a training. There is no explicit learning. That's why I'm right. That's why we are writing. There is no learning. That's why we are saying it's a lazy learner. Yes. Anyway, just let me go back. This is about 273. What it says. Let me discuss about this particular lecture. What is this 274? Yes, this is actually in this particular session, my intention is to explain overfitting and underfitting. Maybe I think I have maybe 25 minutes. Let me complete till that stage. If I complete overfitting and underfitting, it will be helpful. I will try to complete that part. Yes, my dear friends, we were saying how to pick right K. That is important. Yes, we will see how to pick. Not now. Time being, just say K equal to 3, 5, 7, odd number. At least we have got some justification for choosing K as odd number. Again, I am repeating, if K is even number, we will get a problem. If it is K equal to 4, you will get 2 positive neighbors, 2 negative neighbors, you cannot decide. If there is a tie, it will be difficult to determine its class level. That's why ideally always take K is an odd number. Which odd number you have to take, that we will discuss, isn't it? Yes. Here in KNN, K in KNN is hyperparameter. My dear friends, all machine learning students must understand what is parameter, what is hyperparameter. Today's session, in today's morning session, we were discussing about TSNE, T-distributed stochastic neighborhood algorithm. That there is a one blog related to TSNE. There we have seen perplexity. If you change perplexity, your data point classification will alter. Perplexity is a parameter in the case of TSNE. Here, in similar manner, in KNN, K is the sorry, it's not parameter. Perplexity is hyperparameter. Perplexity is hyperparameter. Perplexity is hyperparameter in KN. In Disney. In similar manner, K in K nearest neighborhood is hyperparameter. For example, just try to recall linear regression. What is linear regression? P0 plus B1x. Here parameters is B0 comma B1 are parameters, isn't it? These two are parameters. But here it's not like this is hyperparameter. Maybe normal distribution also e power minus half x minus mu whole square by 2 sigma square. Those are known as parameters. They will decide the shape of the normal distribution curve, something like that. Anyway, this hyperparameter, how to determine all those things, just wait, maybe this session may not permit me to discuss finding hyperparameter. I will discuss how to find hyperparameter in next session. That is in tomorrow's session. There is something like cross validation. In this particular session, let me restrict myself still underfitting and overfitting. Yes. Now we will try to understand decision surface. Yes, what is this decision surface? That name itself says decision surface. This is a surface. Why people are calling, if it is two-dimensional, people used to say line, isn't it? If it is three-dimensional surface, if it is something like that, that's why people used to say in general, they used to call a surface, isn't it? Anyway, we know this representation. Blue means positive, red means negative points. But students, I request all students while writing exam, just keep this blue point as negative symbol. Blue point as positive symbol, red point as negative symbol. While writing exam, you cannot keep these colors. Actually, I myself did a mistake. Instead of keeping these colors, I might have kept plus symbol for positive label, minus symbol for negative label. Anyway, it is recorded, already posted long back. Maybe I don't know, 2 years back. I just try to check it. I don't know how many months or years back I did it. Yes, it's okay. This actually, if you see, if you observe these data points, if I ask a student, a simple boy, a simple elementary school student, how he can classify things, he will keep all red points one side and all blue points other side. But here I have one difficulty. My dear friends, please try to concentrate. Actually, major problem is actually let me go back. Actually, this is useful. Why we are discussing this one? There is something like overfitting and underfitting in machine learning. Let me say like this. Just I'm searching. Let me say image search. Just see, there are so many. Just see that these are pictures. Appropriate fitting, underfitting, overfitting. You will get so many images, isn't it? In order to understand overfitting, underfitting in detailed manner, actually why I opted this particular KNN algorithm, it is very easy to explain so many concepts in machine learning with the help of KNN algorithm. Yes, why we are introducing this decision surface, only simple reason is to explain overfitting and underfitting, nothing more than that, simply nothing more than that. If I ask one student to separate these 2 points, he may draw a line like this, isn't it? Yes, but still here I have a difficulty. Left side of this particular surface, let me say surface, this one, otherwise curve. If it is 3-dimensional, I can say surface. If it's 2-dimensional, I can say it's something like line or curve. On left side of this particular surface, I have negative points. On right side, I have positive points. Unfortunately, there is one misclassification. Which one is misclassified? There is one blue point on red side and there is one red point on blue side. 2 points are misclassified. 2 points are classified wrongly. They are not, the 2 points are classified incorrectly. This one, isn't it? Now what I have to do, isn't it? Actually, if I speak strictly, yes. Now, just the second diagram, what happens? Left side of the surface, all the points, left side of this curve are red points. All the points, right side of this curve is blue points. Means it is strictly separated. No error, isn't it? Why? Because you strictly separated You strictly separated your positive points, negative points, your blue points, negative blue points, and red points, isn't it? Yeah, actually what it is. How we will try. This is first one is case one, second one is case two. What is the difference between case one and case two? In case one, you have very smooth curve. It's a smooth curve, isn't it? Where you have decision surface. In case one, you have a decision surface